Hey everybody, welcome to a new series I plan on making for Maisam for his coding journey. We're going to be attempting Leetcode question 2, which is a medium add two numbers, and I'm using JavaScript. He uses Python, but I plan to specialize in JavaScript um mainly for, you know, web development uh reasons, front end, and you can also use it for the back end, Node.js, Express.js, Next.js, they kind of build on each other. But anyways, it's really good though. That's such a versatile language. I tried Python before. I don't know. It's like it's too like I've learned to think like a programmer, but then the way Python is like English, bro. You can literally use the is word is. Not to say like there isn't like already in programming English type of language. Well, it depends if you're using higher or low level languages. But anyways, today we're doing add two numbers. So you are given two non-empty linked lists representing two non-negative integers. So here's our first linked list. Here's our second linked list. Both non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. So each of these one nodes contains a single digit, and then you have a pointer to the next node. Add the two nodes and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except the number zero itself. So 2, 4, 3, 5, 6, 4, 2 plus 5, 7, 4 plus 6, 10. So 0, carry over to the next digit, 3 plus 4, 7 plus 1 is 8. So this means that we need to abstract the rightmost digit, and then the leftmost digit, which is going to be the carry, needs to be added on to the next node. So for example, 6 plus 4 is 10, right? You can't add 10 here. You have to add the rightmost digit, which is 0, and then 1, right, which you carry over to the next node and add it there, because 3 plus 4 is 7, but plus that 1 carry that we had from this node value is going to be 8. So let's get started. Let's first create a carry variable. So we'll say let, because we're going to keep updating this or reassigning this variable. So we're not going to use const. Let carry equals 0. We will say we'll create a node. Let result, our resulting node, right here. This is where we're creating our resulting node, equal to new list node, and we'll just give it a dummy value of -1. And then since we're going to be keep on iterating, so for example, we have -1, right, where we start from, but then when we keep adding or populating a resulting linked list, we're going to have 7, then we're going to have 0, 8, and we're going to keep adjusting our pointer. And since this isn't a doubly linked list where you don't have a pointer going back, so we have to keep track of our head. So we'll create a dummy variable, so let dummy, and we'll just set it to result. And this will keep track of the head. The head will be -1 because we initialize our result linked list with a -1, but when we return it, we'll just do dummy equals dummy.next. And since these are objects, we know that objects are called by reference. So when we set dummy to result, they both point to the same place in memory. They both point to the same linked list that we're creating. Okay, so while L1 and L2 both have nodes and our carry is not null, we need to do some things. We need to go ahead and add these two values. So we need to extract them. So let L1 value equal, if L1 has a node, then we'll extract L1 dot val. Otherwise, we'll set it to 0. And then let L2 val equal, if L2 has a node, we'll set it to L2 val. Otherwise, we'll set it to 0. So this is a ternary operator, where essentially we have a condition. If this is truthy, we execute this. If it's falsy, we execute this. So we're just checking, does L1 actually have nodes? If they do, we get the L1 value. Otherwise, we just set it to 0. Okay. And now we need to extract the value. So we'll say let result digit, right, from our addition, result digit, equal to L1 plus L2 plus our carry mod 10. And this is to get the rightmost digit. And once we do this, we can say result equals result.next equals, so we're not working on result. We don't want to corrupt the value we already have on result. We want to go to next. Result.next equals new list node with our result digit as its value. And then what I want to do is I want to say result equals result.next. So we point to the next value now, or the next node, I should say. We point to the next node. So now result is like on -1. It's not pointing to 7. We said result.next equals 7, but we haven't adjusted our pointer to point to 7 yet. So now we're pointing at 7. Result equals result.next. And now it's going to keep doing the same thing, but now we have to take into account for the carry. So we're going to reassign the carry now to be math.floor L1 plus, sorry, I should do that, L1 plus L2 plus carry divided by 10. And this is to get the rightmost digit. Or this is to get the, sorry, this was to get the rightmost digit, if I said otherwise, and this is to get the leftmost digit. And now it's already taken into account in this formula right here to get the digit. So when we go to the next one, we'll take into account for the carry. For this one, it would have been 0 because 7, 5 plus 2, 7, there's no carry. But as we keep going, we're going to take into account the carry. For the last, or for the values, when we add them L1 and L2 at 3 and 4, or at 4 and 6, which results in a carry. And we go to this one, 3 and 4, and we need to add that carry to it. 3, 4, 7, plus 1, 8. So now we're going to just point L1 and L2 to the next node. So we're going to do L1 equals, if L1, sorry, this also should be L1 dot value. We're working with the value. We're not working with, it should be L1 dot value. We extracted the value, right? And this should also be L1 dot value. No, sorry. It should be L1 val, the literal variable we're working with. Yeah, so now we're just checking, does L1 have nodes? If it does have nodes, then we'll do L1 dot next, otherwise set it to null. If L2 has nodes in the linked list, we'll set L2 to point to the next node, L2 dot next. Otherwise, we'll set it to null, meaning if, for example, there's no more nodes after this, like 3, we won't set it to next. Obviously, we'll just set it to null because the tail always points to null. And that's basically it. And now we can get out of this while loop and say return our dummy dot next, because right now it's pointing to -1, but we want to point it to the next node, which would have been 7. And there you go. Really fast solution, runtime 0 milliseconds, and there you go. So this was the Leetcode Medium. I hope you enjoyed, and hope you learned something new.